Right, so we're going to look at parametric integration. Now, if I was to find the area between a curve y and the x-axis, I would integrate y with respect to x, and y would be a function of x. All that's going to happen when we do parametric integration is you're going to be given a function of x in terms of another variable, possibly t, y in terms of that same variable, and all you're going to do is you're going to rearrange this using the chain rule. You're still going to have y there, but instead dx is going to be written as dx dt, and then you're going to multiply, or it's the effect of multiplying with dt. So you can see that in theory your dt's would be cancelling each other out in the way the fractions work. So that's how we're going to do our parametric integration. So the question we are looking at is from paper 3, set 4, and it's this question here. So we've got a diagram showing the curves with parametric equations. X equals the natural log of t squared minus 4, y equals 4 over t squared, and we're being really vigilant and spotting that t has to be greater than 2. We'll need that in a moment. We are going to find the area of the shaded region. Now you could form a Cartesian equation by eliminating your variables, your t, and it does actually ask you to do that in part C, but you're not going to be able to do that for the first parts of the question, and that's 12 marks worth, because they have asked you to show that an area can be written in a certain way. So you are going to have to do parametric integration. So the first thing you're going to do is you're going to rewrite y dx dt multiplied by dt. Now y is 4t squared, 4 over t squared, dx dt. Now if you go back, you can see that x is ln of t squared minus 4, and you're good at differentiating using ln. You take the reciprocal of what you're taking the log of, and you multiply by the derivative. So dx dt is going to be 2t over t squared minus 4. So you're then going to multiply, so by 2t over t squared minus 4 multiplied, or integrating that with respect to t. So instantly you can see that those t's are going to cancel, and you're going to end up with an integral as integral of 8 over t bracket t squared minus 4 dt. Now you're almost there. Your only issue now is your limits, and you can see that if you look back at your limits, you had x is ln t squared minus 4, and your x value, your larger x value, was ln 12. So you know ln 12 is ln t squared minus 4. You're taking natural logs of both sides, so you can think of those as 12 is t squared minus 4, so t squared is 16. T would be plus or minus 4, but of course in the question at the beginning it did say that t is greater than 2. So t cannot equal minus 4 as t is greater than 2. I would mention that. So you've got your upper limit, which is 4, and then you're going to work out your lower limit. So your lower x value, so exactly the same. Your lower x value, we had x is ln 5. So you're going to have ln 5 is ln t squared minus 4. So you're going to again get 5 is t squared minus 4, and just as before, t squared is 9, t is going to be plus or minus 3, t is greater than 2, therefore t is 3. So if you go back and look at part A, you have done 4 marks worth of work, and A and B have been determined. They are 4 and 3. Now in part B, you need to show detailed reasoning. So in part B, so even if you weren't able to do part A, you would be able to have a go at part B. Now it's integration, and you are going to be integrating the function that you have in part A. Going through your checklist of how you integrate a fraction, you can't split it up over a common denominator, you can't divide the numerator by the denominator, you can't use your ln, but you notice that that denominator will factorise. So you are going to use partial fractions. So you will set up your factorised denominator. Everything has a linear, your denominators are linear factors, so you will set it up as you are used to doing so. That's t minus 2. Now I know you're good at partial fractions. What's going to happen here is when you work them out, you're going to get A is negative 2, B is 1, and C is 1. So your integral is going to become a much more straightforward integral between 4 and 3 of negative 2 over t plus 1 over t plus 2 plus 1 over t minus 2 with respect to t. So much more straightforward, but it does say show detailed reasoning, so you're going to put this in carefully. You're going to have ln t plus 2 plus ln t minus 2 with your limits going in. Make sure that you clearly, because it says detailed reasoning, make sure you clearly show your limits going in. Otherwise, you're going to lose marks. By all means, check it on your calculator, but make sure you show everything so that you are not going to lose any marks. I've substituted my limits in here, minus 2 ln 3 plus ln 5 plus ln 1. Again, show plenty of detailed reasoning. We're going to end up with ln 12 times 9 all over 16 times 5, which is going to be ln 27 over 20. And then the last part of the question, asks you to write, we can just go back, look at part C, asks you to find the Cartesian equation in this form. So if we look at the Cartesian equation, all that asks us to do is eliminate t. So I'm going, and it also wants it in the form y is a function of x. So when I first looked at it, I thought, oh, I'll rearrange and I'll get t squared is 4 over y, but that's not going to help me. I'm going to rearrange this one here so that I can substitute it in straight into my y function. I know that x is the natural log of t squared minus 4, so I'm going to make those powers of e, so I'm going to end up with t squared minus 4 equals e to the x. I now know from there that t squared is e to the x plus 4. So what I'm now going to do is take my function of y, and my function of y is 4 over t squared. I've got a new form of t squared, so all I'm going to do is substitute that in. Y equals 4 over t squared, and I have y as a function of x.